good morning, good afternoon, good evening, whatever the time is when you're watching this. Yes, so here we are to discuss a mathematics topic, permutations and combination, and it's a really very interesting one. So stick with me and learn what is it. So the first question that might hit your head would be, what are permutations? What are combinations? So they can be easily understood by knowing that they they are a method to calculate the number of ways in which you can possibly do some work. So, in the language of mathematics, I can say that a combination is a mix of different elements or objects. Maybe that means the same in English too. So, a word is a combination of letters, and there are many more examples, right? So, what are permutations then? A permutation is simply an ordered combination. It means that if you change the order in which the elements are present in a combination, and that new combination is considered to be a new combination, then they are permutations. Yes, it might be a bit confusing, but let's see an example, so don't worry. Okay, so I give you 4 letters A, B, C, D, and I tell you to select 2 from them. So how many ways in which you can do that? If the first condition is that the order in which you select the object or letter does not matter, and the second condition is that the order in which you would select them does matter. So these are actually 2 different questions, but I just combine them, club them, so that you can understand better. So when the order doesn't matter, you can just randomly select 2 of the 4. So from ABCD, you can make these combinations: AB, AC, AD, BC, BD, CD. Right, 6 of them. So when the order does matter, so here you need to look out. AB is a AB is a combination, but also BA is one combination. So because the order here does matter. So these are permutations rather than calling them combinations, right? So we have AB, and for that we have BA. For BC we have CB. For AC, CA, and so on. So as you can see, we have 6 combinations and 12 permutations, isn't it? But these we could calculate because the numbers were small. There were only 4 letters and we need to choose 2 of them. But when there were 26 letters, and if I told you just select 5 of them randomly, that would be a terrible job to do. And if I tell you that the order does matter, oh my god, you might just spend your whole life calculating that. But welcome to mathematics, and mathematics always gives you a formula to make your job easier. But this formula might be really very frightening if you look at it for the first time, but I'm sure I will be able to make you understand all the terms behind it. So here you go. Yes, it's really very frightening, but no need to get afraid. I'm going to explain everything. So this is NCR and NPR. This is read as NCR or N choose R. So we have NCR is equal to N exclamation mark. No, that's factorial. That's read as factorial. So now on you need to read it as factorial in mathematics. So NCR is equal to N factorial upon R factorial into N minus R factorial. For the permutations, we have NPR is equal to N factorial upon N minus R factorial. So when we say NCR, we are trying to calculate the number of combinations, and when we are saying NPR, we are trying to calculate the number of permutations. What is this N? What is this R? What is this N factorial? Really very confusing. No need to worry. I'm going to explain each and everything. So these are just a shape, or these are just shapes or symbols. You can understand that these are a cryptic message to the readers, that by this we mean something else, correct? So these are just symbols which tell the reader that it does not mean the same thing as you are thinking, but something else. NCR and NPR, as I said, are the formulas to calculate the combinations and permutations. But what are N, what is N, what is R? So N is the number of objects you have. So out of N objects, you need to choose R objects. So you had 4 letters that time, right? And you need to choose 2 of them. So there the n was 4 and the r was 2. So it would have become 4c2. But to generalize it, let's call it NCR or n choose r. And the same goes for NPR too. But for the NPR, we mean that we are calculating permutations rather than the combinations. So what is n factorial? Yeah, what is factorial? So this exclamation mark is read as factorial, and as I said, it's just a cryptic message to the reader that it just means something else, not exclamation mark but factorial. But this cryptic message is not cryptic now because everyone knows it. So let's see what is n factorial. N factorial is this short form for this such a big expansion. N factorial is n into n minus 1 into n minus 2 into n minus 3 into n minus 4 into n minus 5 into dot 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 into 5 into 4 into 3 into 2 into 1. So you see such a big expansion. So if it's n factorial, you start from n and right away end at 1, multiplying each and every integer that comes in middle. So you see n factorial is defined only for positive integers, correct, and even for 0. Right, so let's see examples. 5 factorial. What's 5 factorial? 5 factorial is 5 into 4 into 3 into 2 into 1. Quick maths is 120. So let's see what's 7 factorial. 7 factorial is 7 into 6 into 5 into 4 into 3 into 2 into 1. But if you notice over here, something hidden over here, you can see 5 into 4 into 3 into 2 into 1 is nothing but 5 factorial, isn't it? So 7 factorial can be read as 7 into 6 into 5 factorial. So it makes our calculations easier and quicker. So 7 factorial is equal to 5040. And here's a tricky question I need you to solve. 0 factorial isn't 0, it is 1. How in the world? I need you to solve it and post this solution, this proof in the comment section. I need you to prove 0 factorial is equal to 1. Yes, it's challenging but quite easy, and I truly believe you could do that. So let's go further and see a few examples. So I have just written down the formulas in the right so that it becomes easier for you. So let's see 4C2 from the previous example. So we had 4 letters and we needed to choose 2 of them. So 4C2. Here the n is 4. The superscript is always n and the subscript is always r. So the superscript here is 4 and the n is 4. So, and the r over here is 2. So 4c2 is equal to 4 factorial upon 2 factorial into 4 minus 2 factorial. And when you expand these and solve it, you would get as 4 into 3 into 2 into 1 upon 2 into 1 into 2 into 1. So when you solve this, you get it as 6. And guess what? The combinations we had got in the previous example where we had letters was 6, right? So let's see, we had even calculated the permutations. We had got 12 permutations. So let's see if that works out for 4p2. So what's 4p2? 4p2 means n is 4, r is 2. So 4p2 means 4 factorial upon 4 minus 2 factorial, isn't it? So when you expand it and get the result, it is 12, correct? So you see, it just makes the calculations so very easy. Now just think, if you had 26 letters and you needed to choose 5 of them where the order doesn't matter, correct? So how many combinations would that make? I need you to solve that and post it in the comment section. And even a short exercise for you, what's 5c3 and what's 5p3. You can solve it on your own and pause the video if you need it. Let's go further and solve a question. So there are 15 children in a park and you want to play some game that needs 11 people in one team. So you need to be not to be partial, and you need to select 11 of these 15 children. So in how many ways can you make a team of 11 if you need to randomly select any 11? Correct. So I need you to pause this video and think over it. Assuming you have done that, let's see the solution. So it means that you have 15 objects, you have 15 people, out of which you need to select 11. You need to choose 11. So that means you have to choose 11 from 15. 15 choose 11. So that is 15C11. And when you apply this simple easy peasy formula, you get it as 15 factorial upon 11 factorial into 15 minus 11 factorial, and you get the answer as 1365. And yes, there are 1365 ways in which you can make a team of 11 just from 15 players. Isn't it amazing? Maths is always amazing. let's give a twist to this question. There are the same 15 children in that park, and you need to make the same, not the same, you need to make a team of 11, right? But here's the twist. The first player you select would be the first one to play, and in the terms of cricket I would say opener. So the first player you select would be the opener, the second would be the non-striker, the second one who will play, the third you select would play third, and so on. You get it, right? So in how many ways can you make such a team? Think over it. This is a twist. Assuming you have paused the video and thought about this question, let's see the solution. So you see this special arrangement of the players. There are 15 players same, and you need to make make a team of 11. Same, isn't it? No. This time the first player you select has to play first, and second player you choose has to play second. It means that if you had two players in the bank, A and B, and if you choose for A the first and B the second, then A would be the opener and B would be the non-striker. But if you chose B the first, then B would be the opener and A would become the non-striker. And you see, these are two different teams because it matters a lot, right? So the order does matter, and when the order does matter, you need to calculate the permutations, and you're very smart enough, you need to follow the NPR formula. So the N over here is 15 because you have 15 guys, and the R is 11 because you need to make a team of 11, and you just apply 15p11, and that comes as 15 factorial upon 4 factorial. So you see, this would become a very, very, very large number. You need not solve it completely, you just need to understand this concept. So let's see this final example. This is a bit tricky one. You need to calculate the number of rectangles in this figure, and I'm giving you a hint. You have to you have to use the concept of permutations and combinations in this question. Assuming you have paused this video and thought about it, don't worry if you just did not realize how in the world can we use permutations and combinations in this, but there is a way. If you see, just to make a rectangle you need two vertical lines, isn't it? And if you choose any two vertical lines from these many vertical lines and join the ends of the vertical lines, it would make you a rectangle. It would form a rectangle for you. Correct, isn't it? So what you need to do is choose two vertical lines from all these vertical lines. So if you count 1, 2, 3, 4, 9, 19. So you have 19 vertical lines, and you need to choose 2 out of 10. You're very smart, I know. And you see, the order in which you choose the vertical lines does not matter. If you choose the last one first and the first one last, it makes the same rectangle. So you need to just find the combinations, and when it's combinations you need to use the NCR formula where N is 19, R is 2, NC2 is equal to 19 factorial upon 2 factorial into 19 minus 2 factorial. That will give you 171. So there were a total of 171 rectangles in that figure. So here's how you solve that question with the use of permutations and combinations concept. So I think you enjoyed this video a lot and learned something new, and you see why mathematics is always so interesting, and I hope you had a good time learning.